AI is a tool for the operators to do their jobs. The first problem statement that we wanted to solve was the large factories, they consume a lot of energy, they consume a lot of water in their manufacturing process. And we wanted to make an impact on that, right? Hi, I'm Vipin Raghavan, co-founder and CEO at Haber, an industrial AI startup. One of the things when we look from the outside that we expect AI to solve is somehow AI will be this magic wand that will take over the factory and completely automate the operations of the factory. In reality, is very different from that, right? What AI is doing is it augments the existing team in the factory. The operators still have to operate the factory. AI provides an extension. AI is a tool for the operators to do their jobs much better, to produce more off of the same piece of equipment, to make more consistent quality product. So AI is just a tool, right? So definitely creates a lot of value, but it's not this mysterious black box that just takes over the factory and can automatically run the factory. So one of the things that we have solved at Haber is our customers, these factories, use a lot of chemicals in the process of converting their raw materials to finished products. The quantum of these chemistries are quite large. Before we introduced our AI solution, these chemicals were dosed in a very manual fashion. So samples would be collected of the raw material, of the finished product. Those samples would be walked over to a laboratory facility. Measurements, different types of measurements would be taken on benchtop instruments. And then based on that data, the factory team would decide if they wanted to change the chemical dosing. What we have been able to do is take that entire loop of grabbing the sample, measuring in the lab, analyzing, and making the change. We've completely automated that process into a closed loop fashion, right? So that's a big game-changing tech that we've brought to manufacturing. So the big challenges are the same whether we look at India, emerging markets like Africa, or even more advanced markets like the West, Japan, China. The challenges are pretty much the same, right? The raw materials that these factories get, which are usually natural resources. So if you look at steel, you're starting with iron ore, oil and gas, you're starting with oil, pulp, paper packaging, you're starting with wood fiber. These natural resources inherently have a lot of variation, meaning the quality of these raw materials change from season to season. They change from region to region. So there's inherently a lot of variation in these raw materials. So that challenge is the same irrespective of North America or India. The other big challenge that all of them face is the tenure of their operators. Some couple of decades back, these used to be the most desired jobs in a lot of these places. Blue collar workers had at least 10 years, maybe even 20 years of tenure. Over the last few years, we're seeing these average tenures come down. What used to be 10 to 15 years of average tenure is now in the low single digits. And this challenge is the same, right? Whether you're talking about developing markets or developed economies. The third one is the end markets. Our customers are asking for different types of products. So factories used to produce the same type of product for 30 days straight. Now they're having to switch from one grade of product to another grade of product in the same day, right? So when you switch from one grade to another grade, it takes time for you to make that switch from one grade to another grade, and there's losses that happen in between, right? So the raw materials are changing. The people who are operating these factories, their experience is coming down, and the finished products that they have to make are becoming more and more diverse. So these three broad challenges remain the same wherever we go, whether we're talking about pulp and paper industry, oil and gas, or we're talking about steel or food and beverage processing, or going from the West to India, the challenges remain the same. So we got to start in India. Our The first problem statement that we wanted to solve was the large factories. They consume a lot of energy. They consume a lot of water in their manufacturing process, and we wanted to make an impact on that. Right? How do we make these factories more greener? How do we get them to operate with less energy, make a smaller carbon footprint, have a smaller water footprint? That was the problem statement that we wanted to address. So that was what brought the founding team together. We quickly realized that yes, environmental impact is important to these factories, but what was more important was how does that then translate to dollars and cents. So we quickly pivoted to talking about what is the impact we can have on their P&L in terms of higher production, more sales, lower costs, things like that. And when we started talking about the dollars and cents, that completely changed our traction. We started the customers started to receive us much better, and then adoption just started to happen very quickly. There are multiple things, right? So some of the challenges are becoming more pronounced, right? Scarcity of raw material, scarcity of talent. These challenges are becoming greater and greater as time passes by. The availability of tech at these factories, that's improving, meaning the factories are deploying more sensors, measuring more things, so there's more data. And the other big thing is the factories are connected now, right? So there's internet availability even in the most remotest of factories, and the cost of data transmission and the cost of data processing has come down so much. So the ability to deploy advanced technology like sensing technologies and AI, that barrier has reduced quite a bit. Yeah, so there are many things, right? So many of our customers are in pulp and packaging. So one of the critical things is when the product is forming, how much charge is present in these pulp streams. So that is a measurement that is typically done in a lab. So they would grab a sample of the pulp, walk it over to a lab, do the charge measurement, and then decide what to change in the process because the charge has changed, and that is a critical parameter, right? So what we have been able to do with Elixir, which automatically samples this pulp, measures, what we have been able to do is indirectly figure out, what how do we have parameters that can show what the charge would be, and then use that data to control the process parameters like the chemical dosing. So at the end, what we are essentially doing is we are enabling our customers to make consistent quality product, even though some of the input variables are changing. So the journey is quite interesting, right? So we start off by using existing data sets that the factories have, combining that with the data that our sensors are generating. Now, once we have this data set, we are able to forecast, predict quality parameters in real time. So some of these processes might take up to 2 hours. So if you make a change right now, you won't see the impact of that change for another 2 hours. So if you are able to predict what's going to happen after 2 hours, that is hugely valuable, right? Now, once that prediction is made, we can use that prediction to make corrections to the process in the present. Now, the way we gain confidence of the operators in the plant is by showing them these predictions. And once they see that these predictions are relatively accurate, there's a very high degree of accuracy, right? 90-95% accuracy in these predictions, they gain a lot of confidence. And then the next step is using these predictions to control the process in real time. So that's our journey. So we don't go in and say, hey, right away we're going to deploy and start controlling your process in a closed loop fashion. We will first prove to you that our predictions are reliable. And once you have that confidence, the next stage is we use these predictions to control the process in the closed loop fashion. So it takes some time, right? It's a journey. We go through that in phases. It's very important to get shop floor buy-in, not just the management team and the C-suite, but also the folks who are working on the shop floor. Getting their buy-in is super important. There are multiple things in our tech stack that we're very proud of. The edge computing itself. So we have our own edge computing architecture. What that enables us to do is we are able to process these very heavy machine learning algorithms at the factory site instead of having to send all the data to the cloud and doing all the processing in the cloud. We are able to do that at the edge site. We've optimized our ML models so that those can be run in these on the edge computing devices. So that the edge computing device, the architecture, that's something we are very proud about. The whole closed loop control of chemistry, that's something that we are very proud about because it's the intersection of many different disciplines. It's not just data science, but it's also process knowledge. It is the knowledge of chemistries. It's all the stuff coming together that has enabled us to do closed loop control of chemical dosing. Yeah, so our main value proposition to our customers who are factories that are making tissue or packaging is to help them improve their throughput, right? So from the same quantum of raw material, they're able to make more finished product, uh, to help them make more consistent quality products. So let's say their rejection rates were 5% on an average, bring that down to zero, right? Help them reduce their water, energy, and chemical footprint, right? So those three are the main value propositions that we give our customers. So many customers, one that comes to mind is one of the largest tissue manufacturers in the region, right? So the strength property of the tissue is very important. It's a critical quality parameter. So Elixir, our product, predicts the strength property in real time and makes adjustments to the process so that the strength property is consistently achieved. So before we deployed our technology, this particular manufacturer was rejecting about 4% of the product, right? So 4% of what they're producing doesn't meet quality specs, and then they have to reprocess it. The worst case scenario would be they would not catch the quality defect and ship this tissue to their end customers, who would then send like a complaint, right? So that would be the worst case scenario. So once we deployed our algorithm, we were able to completely eliminate the quality issue, which was of huge value to our customer. Yeah, so one of the options was to just sell the hardware or sell the hardware and then give the software subscription, right? But what would have happened in that situation is the chemistry that the customer is using, if they change their chemistry, the algorithm would have to get fine tuned to the new chemistry, right? Uh, so by packaging everything as one solution, we had more control over what the chemistry was doing for the product that the customer was making. And it made more logical sense by packaging hardware, software, and chemistry, and then committing to the customer on productivity, quality, and things like that. That became the right model for us to play with, and was hugely successful in the market. Yeah, so one of the things that we are very proud about is we have zero churn, right? Uh, not a fair comparison, but our product is like a pacemaker, right? Once the pacemaker is inside the body, you're not going to take it out. So similarly, once we are inside of a factory never removes us, because what we're doing for these factories are we are reducing variability in their process, and the minute you pull the product out, the factory goes back to the older state, which is more variation, more quality related rejections, lower productivity, all that stuff, right? And how we then ensure that the customer is reminded of the value that we are creating, right? So we have a very strong customer success team. So customer success is built into the DNA of every function in the company, and we make sure that we are merchandising the value frequently back to the customer, reminding them that this quarter your productivity was higher by 10% because of our product. This quarter your quality rejections were lower by 80% because of our product. So this merchandising this, the value that we are creating back to our customer, that's very core to how we retain our customers. So our product is a combination of hardware, software, and specialty chemicals. So the way we price it is we have the solution and then we price it on a price per ton of production. So assume our customer is producing 20,000 tons of product. They pay us $5 per ton of what they're producing. So 5 times 20, they pay us $100,000. So that's how we price for most of our contracts. Sometimes we might split it up and say, pay us a one-time upfront fee to install the hardware, pay us a separate subscription for the software, and then pay us for the chemical consumable separately. But most of our contracts are priced in that price per ton of production model, which is a win-win situation. If the factory is producing more, we also win with them. So cultures are a little different as we go from India to the West, especially, right? The Western markets have been used to working with a very small footprint of manpower. So if the average Indian plant is operated by a team of 100 people, when you go to the West, that number might be half or even less, right? So they're already used to running their factories with lower manpower in a more efficient fashion, and AI adoptability is also slightly different because of those reasons, right? In India, adoption can happen from a more of a top down approach. If the supervisor is asking the operator to use AI, they just do that. In the Western markets, the operators have to be convinced, have to buy in themselves to adapt AI. So many of our large enterprise customers are not just one factory, right? They are a network of factories. So when we sign a contract with these customers, we sign it for one factory, one production line. And then there is the opportunity to replicate what we do on their other production lines. So there's a lot of headroom to grow, especially with the enterprise customers. Some of them have tens of factories, right? So that is one if you're doing a great job on one production line, then there's a very high chance that they're going to ask us to repeat what we are doing on that production line on a different production line. So more than half of our growth comes from our existing customer base, because we are replicating what we do in one factory over to another factory within that same customer's network of factories. So the challenges in the West and in developing markets like India are very similar. Raw materials come from the same places. The markets are very similar, what the markets are demanding in terms of variety of grades of products. So the factories have to be very flexible in terms of manufacturing. Talent scarcity is everywhere, not just in the West, but here in India as well. So the challenges remain the same, but obviously there are cultural differences. Uh, Adoption of technology is one area where we've seen some of these cultural differences play out. Operators in an Indian factory can be told to adopt a new technology. In the West, uh, the operators have to buy in themselves. They're not generally told to start using something. So adoption of technology, the journey of adoption becomes slightly different when you move from India or developing markets to the Western markets. Yeah, so when we started Haber, we wanted to go horizontal, right? So we knew that our product can be applied across many different industries, and that's the path we wanted to take. Somewhere along the line, we found pulp, paper, packaging, tissue, the fiber-based manufacturing industries. We found those as our niche space, and we started going very deep into that industry. That was, in hindsight, that was a fantastic call to focus on that just one industry. Today, even though we have customers in other industries, more than 80% of our customer base is in pulp, packaging, paper, that industry, and more than 80% of our uh, people, our team, is focused on that industry. So in hindsight, that was a great call. We ingrained very deep in that industry today. Our brand is very well known in that industry, and we've been able to geographically expand quite fast because we have case studies of success stories in the industry from different geographies. So we like to bring on board people who are what I call T-shaped skill sets, right? They're very deep on one area of expertise, but they also don't mind going horizontal a little bit to adjacent areas, because most of the problems that we are dealing with are multidisciplinary in nature, uh, and just having experts in one domain who are not interested in working across domains will not work for us. So we try to find people who are good in their respective domain, but who like to work across domains. That also helps us filter through talent, because we make it very clear that this is not just about working in data science. It is also about understanding process. It's also about understanding chemistry. So when we hire data scientists, we hire the kind of data scientists who like to go across domains and not just work in data science. So that's one important feature that we look for in talent. The other is, we look for people who share the company's vision, right? People who can truly empathize with our customers. And who are our customers? Our customers are the operators in the factory. They're the supervisors. They're the factory managers. So we want everybody on the team to empathize fully with the challenges that our customers are facing. Yeah, we had lots of challenges, right? Lots of teething issues. Sometimes we go live, we assume a sensor is going to work, but then we realize that the particular type of raw material that we are dealing with is is very different from what we've seen in the past, and we have to make certain adjustments, or the models don't work right away, right? And we have to do some retraining on the models, things like that. Those are early teething problems. I like to believe that there are not as many issues as we go live today. But in the early days, we have faced all kinds of challenges, right? We are edge computing is our own architecture. The first version of it was a little buggy, right? So it would hang, right? Sometimes the memory would get overloaded and it would hang. Over time, we've gotten really good at edge computing architecture to make sure that uh, the devices work 24/7. They can deal with processing. They can deal with the data, and they will never break down. They always do what they're supposed to do 24/7, 365 days. So one of the reasons that the founding team came together was to solve this multidisciplinary problem and have a big impact on the environment. So our first thesis was, we know factories consume a lot of energy power, um, and we also know that factories consume a lot of water. So how do we help these factories make what they're making with consuming less energy, consuming less water? And we knew that in order to solve this problem, we would have to work on a multidisciplinary problem. It could not just be software, it could not just be hardware. It had to be, all those things coming together. Uh, and uh, and solving for that needed expertise from very different areas. We needed experts in electronics. We needed experts in embedded software development. We needed experts in cloud software. We needed experts on data science. We needed people who understood how these factories operated. So bringing all those diverse disciplines together is why we wanted to start Haber, right? Because we strongly felt that not a lot of people were looking at this problem, were not working on this problem. We knew it was going to be difficult, but we wanted to take it head on. We still are aspiring to get our algorithms to a point where they can almost autonomously operate a factory, right? Uh, Day one, we wanted to do that. We have come a long way, but it's easy to kind of want to get there, but getting it to solve these very messy real world problems, AI is not this black box solution that's just going to come in and solve all of the factory's problems, right? So finding the right areas where the plant operators can leverage AI to create more value for these factories, uh, so that they can produce more, uh, do more with less, avoid issues, avoid breakdowns, avoid maintenance issues, avoid quality issues. That is where the value lies, right? But that aspiration of building a complete autonomous factory, that is the ultimate goal, right? And we continue to work towards that goal. But the big change in the mindset was, we have to take baby steps to get there. Yeah, so AI is the big equalizer. And I see all factories should be taking advantage of AI. There's no excuse for anybody not to be doing this. Uh, Factories in India can be as competitive as the best factories in the world. They can benchmark themselves against the best in the world, and they have to leverage AI to get them there faster. Uh, our purpose is to distribute our product, which is an AI driven product, to as many factories all over the world, right? So we are geography agnostic. Right now, we are focused mostly on pulp, paper, packaging, and tissue. We do want to take our product to other industries. We have references in other industries. But the way I see our journey over the next 5 years is to distribute this great equalizing technology to as many factories in as many places as possible.